A trie returns prefixes fast, but it cannot recover many partial or mistyped terms. Measure it against an edge n-gram index and choose the right autocomplete path. You'll see how to connect the pieces into a workflow that tests autocomplete indexes and chooses one by recall, typo behavior, and cost. I'm Professor Pi, teaching Search and IR with simple Python. Autocomplete shows suggestions while someone types. The hard part is the trade-off between speed, memory, and useful results. A trie gives exact left-anchored matches and feels instant for short prefixes. An edge n-gram index does more work when you index. But then, lookups are flatter and cheaper. Teams pick one when they need predictable latency, or when users type mid-word fragments, or when typos are common. Picture a product catalog search bar. If most people start at the beginning of product names, a trie is lean and very fast. If people remember a fragment from the middle, or you want suggestions from any token, an edge n-gram index returns candidates without deep tree traversal. What matters is how many useful suggestions you return for the real inputs your users type, and how fast those suggestions appear. Intuitively, a trie is a tree of characters where each keystroke walks one level deeper. Edge n-grams pre-compute prefixes of terms and map each prefix back to the original terms. With a trie, you explore nodes at query time. With an edge index, you pay up front for direct lookups. Tries shine on memory and precise left prefix matching. Edge n-grams shine when you want immediate postings lists for many prefix lengths. We'll build a tiny playground that shows both approaches and a simple decision rule. You'll see how lookup work changes, how tokenizing titles helps recover inner word fragments, and how a light fuzzy fallback can cover typos. Keeping the experiment small makes each choice directly comparable and measurable. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now we start by creating the minimal trie and testing a single prefix path to show the fast left-anchored case. This snippet builds the smallest useful prefix trie and checks one prefix path. A trie is attractive when users type from the beginning of a term because each character sends us one level deeper in trie. The code inserts each item from terms, stores the full term at 0, then follows prefix character by character. If a user types car, the structure can confirm that the path exists without scanning every term. The visible output shows the prefix was found, which is the fast happy path teams often optimize first. Next, we show the edge n-gram alternative, which prepares direct postings for every leading slice so lookups can jump to candidates. This example builds the inverted index version of prefix autocomplete. Instead of walking a tree, Edge maps every leading slice of each term to the terms that contain that slice as a prefix. The query do becomes a direct dictionary lookup, and sorted edge do gives stable results for the screen. This is the same intuition behind edge n-grams in search systems. Pay more at indexing time so lookup can jump straight to candidates. Increasing the maximum n-gram length improves coverage for longer prefixes, but grows the index. The visible output shows the postings list for do, which matters because ranking can start from that candidate set. Now compare how much work each structure does for the same prefix so we can feel the trade-off in lookup effort. This code compares the amount of lookup work after both structures already exist. Walk follows the prefix in trie, then explores the remaining subtree to collect completions, so broad prefixes can still touch several nodes. The edge n-gram path uses edge.do, which is a direct postings lookup, plus the cost of reading the candidates. This is a small proxy for latency, not a benchmark, but it makes the trade-off visible without noisy timing numbers. The visible output shows less lookup work for the edge index on this prefix, which matters when broad prefixes are common. The strict whole string trie often misses useful mid-string fragments, so we change how we index to recover inner tokens. This snippet shows where a whole string trie starts to feel too strict. Full trie indexes complete titles from the first character, so it naturally likes queries such as read, not a later word like show. Token edge changes the unit of indexing. Each title is split into tokens, and the first 3 characters of each token point back to the full title. That makes partial word recall explicit, instead of hoping the user's input starts at the beginning of the full string. The visible output shows titles reached through the token prefix show, which matters when users remember product words out of order. Finally, we wire a simple decision rule that uses the cheapest precise lookup first and falls back to broader or fuzzy paths as needed. This example turns the comparison into a tiny baseline decision rule. Autocomplete first tries walk try queue because exact left prefix lookup is cheap and precise when it works. If that fails, it checks token edge, so a partial word inside a title can still produce candidates. Only after both structured indexes miss does it call get close matches as a lightweight typo fallback. In larger systems, that role is often handled by a dedicated, fuzzy retrieval stage. The visible output shows which route each query used, which matters because the index choice should follow the input behavior you actually need to recover. If you took this toy experiment into production, map terms to your catalog of titles, and token edge to a tokenized field in your search index, that keeps the fast left prefix path for common starts, while token n-grams and a separate fuzzy stage catch mid-word fragments and typos. In short, a trie is a character tree that excels at left-anchored typing and minimal index cost. Use an edge n-gram index when users type mid-token fragments or you need constant time postings lookups. Watch out! Edge indexes grow with n-gram length and can increase memory and indexing time. A practical next step is to tune the maximum n-gram length used for token edge and measure candidate recall on your real user query logs. Increase it until recall stops improving for your top queries. Then monitor index size and index time to find the balance. If you want more practical search builds, subscribe and watch the other IR videos.